welcome to Indus Technologies with one more interesting video in which we are going to find out whether the number is Armstrong number or not, and we are going to find it with the help of flowchart. So I'm going to draw a flowchart which will find whether the number is Armstrong number or not. So the question is, what is Armstrong number? Suppose I have a number 153. I have to find whether this number is Armstrong or not. So I will check this 1, this 5 and this 3. I will find cube of all these digits. Suppose I will find the cube of this 1 cube, 5 cube and 3 cube. 1 cube is equal to 1 into 1 into 1, and that is equal to 1. 5 cube is equal to 5 into 5 into 5, and that is equal to 125, and 3 cube is equal to 3 into 3 into 3, and that is equal to 27. Now if I will sum up these numbers, 1 plus 125 plus 27, 125 plus 27 plus 1, okay, 5 plus 7 is equal to 12 plus 1 is equal to 13, 3, 1 is carry, 2 plus 2 is equal to 4 plus 1 is equal to 5, and this is 1. So I got the number which it was earlier. Okay, so if I am getting this number, that is same as the original number that it was earlier. This is called the Armstrong number. Now I am going to check whether the number is Armstrong or not. Suppose I have any other number, 381. I have to check in the similar way that whether this number is Armstrong or not. Maybe it could be Armstrong, or maybe it could not be Armstrong number. We have to check it with the help of flowchart. So I will draw a flowchart which will ask user to enter any number, and when user will enter a number, the flowchart will automatically find out whether the number entered by user is Armstrong number or not. So I am going to draw that flowchart. I have completed this flowchart. Now I am going to explain you how this flowchart works, and for that purpose I will draw a memory map for this. So first I am declaring a variable x. So I will write x. It is basically the command read x. So user should have to enter the number which will be assigned into this variable x, and user will enter that number for the purpose to find whether that number is Armstrong number or not. So user will enter, suppose 153. User will enter 153, and that 153 will be assigned to this variable x. Okay, I am declaring another variable sum, and I am initializing this sum to 0. So I will write here sum, and I am giving it a value 0. Another variable temp, temp, and I am initializing, I am declaring this temp as variable, and I am assigning the value x to this temp. So whatever will be the value inside this x, that will be assigned to this temp. So inside x there is 153, and that 153 will be assigned to this temp variable. I am declaring this temp variable because I want to store this value of x, because at last I have to see whether the sum is equal to this x or not. But this x value is changing here. You can see this x value will get changed. So I am storing the original value of this x inside this temp variable. Okay, now the condition is if x is greater than 0. Is this x greater than 0? Yes, this is 153 and this is greater than 0. So what to do next? Y is equal to x percent 10. So I am declaring another variable y whose value is x modulus 10. So I have to find the modulus of this x with 10. So this is x, so I will write it 153, and I have to divide it with 10 to find the modulus of this x. So 10 into 15 is equal to 150, and the answer and the remainder will be 3. Because I am using the modulus symbol, so I have to consider this remainder. I have not to consider this coefficient here. So I have to consider this remainder because I am using the modulus symbol. Okay, so my answer is 3 here. So this 3 will be assigned to this y, because y is equal to x percent 10. Now at the same time, x is equal to x divided by 10. This time it is divided, it is not modulus this time. Okay, so I have to find the division. I have already found the division, and that is 15 here. You can see at the top it is 15. When I was calculating the remainder, at the same time I was calculating the remainder of this x with this 10. If you are not comfortable with this, I will do this step again. This is x 153, and I want to find the division of this x with this 10. Okay, I will divide this 153 with 10. 10 15 is 150, and the remainder is 3. But this time I have not to consider this remainder, because I am going to find out the division, x divided by 10. So the 15 will be the output here. Okay, and that will be assigned to this x. This x will be updated. Last value it was 153. Now I am giving it a new value here. X is equal to x divided by 10, and that is 15. So I will write 15 here. Sum is equal to sum plus y cube. Sum is 0, so I will consider this expression like this: 0 plus y cube. What is y? Y is 3. 0 plus 3 cube. What is 3 cube? 3 multiplied by 3 multiplied by 3, that is 27. 0 plus 27 is equal to 27. So sum will be equal to 27. The direction of my flowchart is like this. I am going this way, and I am looping this. I am going again to this step, because I want to repeat these steps. I want to check whether x is greater than 0 or not. So I will check. If x is greater than 0, yes, x is 15, and still it is greater than 0, and it will again move towards this direction. Yes, y is equal to x percent 10. Now x percent 10 will be 15, because x is 15 percent 10. It will be 10 ones 10, and it will be 5. This time it will be 5, and that will be assigned to this y. So y previous value was 3. Now new value will be 5. X is equal to x divided by 10. You can see here x is equal to x divided by 10. So x is equal to x divided by 10. You can see here, when I was calculating the remainder in the above step, at the same time I was calculating the division here, 1. So when I got this 5 as remainder, at the same time I got this 1 as division. So x will be 1. Okay, sum is equal to sum plus y cube. What is the previous sum? That is 27. 27 plus y cube. What is y? Y is 5 cube. 27 plus 5 cube. 5 cube is equal to 125 plus 27. 125 plus 27. 25 plus 27 is equal to 7 plus 5 is equal to 12. 2, 4, 5, and this is 152. So sum will be equal to 152. Okay, again after finishing this step, my flowchart is commanding that I have to loop the things. Okay, so I have to repeat from here. Okay, so these steps will be repeated. If x is greater than 0, yes, x is still 1, it is greater than 0, so it will again repeat these steps. Okay, y is equal to x percent 10. Y is equal to x percent 10. So what is x? X is 1 percent 10. 10 zeros 0, and the remainder is 1. So y will be 1, and x is equal to x divided by 10. At the same time, when I was calculating the remainder, I was also getting this division also, that was 0. So x will be equal to 0. Okay, and sum will be equal to sum plus y. What is the previous sum? That was 152. 152 plus 1 cube. Okay, plus y cube. Y is, because the y is 1, and here it will be 1 cube. So 152 plus 1 cube is equal to 1, and that will be 153. So sum will be equal to 153. Now we got sum equal to 153. Our flow chart is commanding that I have to loop the things. So if x is greater than 0, this time this condition will be false because x is equal to 0. It is not greater than 0, it is equal to 0. Okay, so this condition will be false and we will be in the no case here. And inside that no case, I have to check whether if sum is equal to temp. What is the value of my sum? That is 153. Okay, if this 153 is equal to temp, I already stored the original value of x. Okay, that was 153. Is this temp is equal to this sum? Yes, both are same. Okay, so the number is Armstrong number. In case it could have been the number that was not Armstrong number, in that case it would have gone through the no case, and we have to print that time that number is not Armstrong number. But in this case, in current case, I have to print number is Armstrong number, and then I have to stop, and in this case also I have to stop. Okay, this was Armstrong number program, or we can say Armstrong number flowchart. Thanks for watching, and don't forget to subscribe our channel Indus Technologies.